Hey everybody, this is Mr. Beckstrom, and today we're going to be taking a look at an example from section 2.4. This is the average rate of change and or the derivative. This is question 2, and it says find the indicated quantities for f of x is equal to 5x squared. So remember, we want to use that slope formula. Just kind of look a little bit like this. Okay, so it's going to be like y2 minus y1 all over x2 minus x1. So in this case here, when we're trying to find it for this function with these points, well, we can call this point x1 here, that's the 1. We can call this point here 1 plus h is x2. We can call f of 1 as y1. And f of 1 plus h as y2. Alright, so now when we plug this into the equation here, we're going to have something that looks more like this. F of 1 plus h, 1 plus h, because that's our y2, minus our y1, which is f of 1, all over x2 minus x1. So that's going to be 1 plus h, and then minus x1, which is 1. Now, before we go too much farther, let's figure out what this is, and let's figure out what this is. This is going to be the harder one right over there, so let's do that off to the side. So I'm going to just plug in 1 plus h for x and see what I get. So f of 1 plus h means to go into our equation f, which is right here, and replace any of our variables, in this case x, with 1 plus h. So it'll look like this. 5 times 1 plus h quantity squared. And that's going to be equal to 5 times, if we FOIL that out, we're going to get a 1 squared, which is 1, plus the inner and the outer terms will give us a 2 times 1 times h, which would just be a 2h, plus h squared. And finally, we can just distribute that 5, and you're going to get 5 plus 10h plus 5h squared. So that's what we're going to replace this with up here. So that'll be 5 plus 10h plus 5h squared. And then we're going to minus, this is the function here, with our x replaced with 1. So here we can just do the order of operations. x1 is just like first. 1 squared is 1. 1 times 5 is 5. So that's just going to give us minus 5 all over. And 1 minus 1 is just 0, so we're just left with an h here. Now notice that this positive 5 and this negative 5 will both cancel out. And then we can factor an h out of each of the terms. So 1h out of here, 1h out of there, an h here. So I should just be left with 10 plus 5h. Remember, you can only cancel out variables in each term when every term has that variable in it, which in this case it's h. And we can only do that because we got rid of these 5s first. So this is your slope of the secant line going through those 2 points. So now we can put in anything for h. Remember, h is our distance that our second point is away from our first point. So the second one says find the slope of the graph at this right here, at 1 f of 1. So here we're going to use the limit definition of the derivative. So let me kind of give us a little bit more room here. And this is going to be, we're going to use this formula here. So that's the limit as h approaches 0 of f of a plus h minus f of a all over h. Now, if you remember, we already found that if our a is equal to 1, and we're using the x value of 1 here, so we've really already done all of the work. So this is just going to equal the limit as h approaches 0, and it's just going to be this right here, because again, if you let a be 1, then this is f of a plus h minus f of a all over h, right? And that's when we canceled out the 1's there. So again, we've done the work, so let's just put this here, 10 plus 5h, 5h. Okay. And then remember, with the limit, if we can substitute and not get that indeterminate form, we go ahead and do that. So that's just going to be plug in the 0 for h, and you're just going to get 10 times plus 5 times 0, which is just 10. So that is going to be the slope of the graph at 1 f of 1. And then the last one says find the equation of the tangent line. Go back. At that point, and we did this in class as well. So what we're going to do here is we're going to use that point slope formula. So if we plug in, let me go down here. If we plug in the 1 into the original equation, that's what this y value is, you get 5. So 1, 5 is the point that we're going to use on our last problem here, C. So again, put this right here. So we have y minus y1 is equal to m times x minus x1. So it's going to look like this here, where our point is going to be 1, 5, and our slope is going to be what we just found here, because we're asking for the slope of the tangent line, 10. So if we plug this in, y minus 5 is equal to 10 times x minus 1. We just need to solve that. So that's going to be equal to y minus 5 is equal to 10x minus 10. Then you add 5 to both sides, and we get y is equal to, got the x right there, y is equal to 10x, and then negative 10 plus 5 is minus 5. And that's it. That will be the slope or the equation for the tangent line at the point 1, 5, or at the x value of 1. All right, if you have any more questions, let me know, and I hope you have a great rest of your day. Thank you.